Hey everybody, I thought I'd do a little educational piece here on the Puget Sound Convergence Zone. If you've lived in Western Washington for any amount of time, you know about the Puget Sound Convergence Zone. I just thought I'd get us all on the same page on what it takes to forecast it and what kind of conditions cause the Puget Sound Convergence Zone. We're also going to talk about the Olympic Mountain velocity shear zone, and that's an area where we can get enhanced rotation of some of the thunderstorms that move in on the south and southeast side of the Olympic Mountains there that form near a lead low, and that's what caused the Port Orchard tornado back in 2018. So checking things out here across western Washington, you can see the dynamic terrain. We have the lowlands across the Puget Sound. There's Vancouver Island, which is relatively high as well. The Olympic Mountains, of course, have some nice elevation to them. Then we have a low gap here called the Chehalis Gap, and this is the Strait of Juan de Fuca here on the north side of the Olympic Mountains there as well. So you can see the complex terrain that does exist, and we have the Cascade Mountains here across the central portions of the state here. We have the Stampede Gap here, and we have the Fraser River outflow here. Here's the Okanagan River outflow also. It's a cold air conduit from central BC into eastern Washington. But for the most part, you can see you go from some pretty high mountains here across the Olympics here to some relative lowlands across Puget Sound, and then we have a gap here for Chehalis Gap and Strait of Juan de Fuca. So now checking this out, you can see this is a map of 925 millibars, about 2,500 feet. You can see low-level winds flowing around the Olympics here, coming through the Chehalis Gap a bit, through the Strait of Juan de Fuca, and actually through the Strait of Georgia here too, off to the east of Vancouver Island, can actually help enhance some of the Puget Sound Convergence Zone activity that goes on. But you can see these winds wrapping around and kind of meeting across the central sound. That's what happens. This air gets forced and rises, and if it's unstable enough, you can get showers, thunderstorms, snow, hail, all kinds of good stuff there in the Puget Sound Convergence Zone. Now let's go ahead and check out what we need to get those conditions. You can see low-level winds have to be within northwest to southwest along the Washington coast. If not, of course, you're not going to get a Puget Sound Convergence Zone. This is kind of in the wake of a frontal system. We'll look at that in some detail as well. So you get this low-level flow running up against the Olympic Mountains and going around it to the north and the south. So if you're not getting that, you're not going to get that convergence zone across the central sound. So as you look here, if you are getting those winds, you need them to last for a certain amount of period of time, at least 3 hours, sometimes more. And if you're not going to get that, you're not going to get the Puget Sound Convergence Zone. You're not just going to get a brief period of northwest winds and then start spawning the convergence zone immediately. It takes a little bit of time for it to form. Now checking this out here. Now, if you've got the winds for more than 3 hours, then you're dealing with the Puget Sound Convergence Zone that is likely. Is the environment unstable? If not, you're probably just going to get stratus fog or drizzle across northern, possibly central Puget Sound. You're not going to get too much dynamic precipitation at that point. No thunderstorms, small hail, snow, usually out of the question for that matter. Now, if it is unstable, which is the case a lot of times post-frontal environment here with that low-level flow, then you're starting to look at showers and thunderstorms likely across northern and central Puget Sound. And of course, if you're dealing with late fall or winter time, maybe early spring, if that freezing level is below 1,000 feet, you got to start to watch out for lowland snow. The convergence zone can really drop the snow level locally and bring snowfall down all the way down to the surface in some areas. And now, the more this veers back to the northwest, the more likely the Puget Sound Convergence Zone is to slide down the central sound and even south of Seattle. The more the flow stays westerly, the more likely that convergence zone is going to stay north of Seattle towards the King County, Snohomish County line. And now, so if it's not veering, you can see no Puget Sound Convergence Zone expected to stay north of Seattle. And that would be in this diagram here, generally westerly flow. You can see winds meeting just north of Seattle here, King County, Snohomish line, maybe a thunderstorm, maybe some snow as you get into the higher terrain. Again, depending on what time of year, the snow can go all the way down to the surface there, of course, as well. Now, this kind of shows a different scenario here where you've got more of a southwesterly low-level flow, and you're meeting these winds further up towards Camano Island, maybe up towards Marysville, the San Juans even, up towards Arlington as you get this low-level convergence happening there. Now here we're looking at winds expected to veer from westerly to northwest. The westerly gradient is increasing. If yes, the Puget Sound Convergence Zone is likely to move south of Seattle, hang up over SeaTac, sometimes even a little bit further south, depending on the exact scenario here. And then as we go ahead and take a look at this, you can see The wind's coming more out of the northwesterly around the Strait of Juan de Fuca, a bit more westerly through the Chehalis Gap and meeting up maybe Seattle south through SeaTac, just a little bit south. Thunderstorms, of course, possible. And during the winter time, sometimes this flow, as it becomes more northerly, this postfrontal flow can be quite cold, and you can get surprise snowfalls all the way down past SeaTac here sometimes during late fall, winter, and early springtime here. So now as we look at things here, this is kind of some of the hail that I got here at one point. I think this was March 2021 here, as I got there was some 1-inch hail reported across some of the Central Sound and down towards SeaTac with this system as this convergence zone slid south across the region here. Now, taking a look here, this is one of the maps I pulled also, and you can see this is one that's progressed past Seattle and probably hanging up over SeaTac at this point. Westerly flow through the Chehalis Gap, northwest coming across the Strait of Juan de Fuca here. And sometimes, again, this branch across the Strait of Georgia here will reach down and create a convergence zone, sometimes north. And sometimes that branch will also kick all the way down through the Puget Sound as well. So now taking a look here, this is looking at 925 millibars as well. And you can see that Strait of Georgia here flow out of the northwest, meeting up with some of the westerlies still coming down across through the Chehalis Gap here. And this would create a convergence zone across the central Puget Sound as well. And especially during wintertime, you're obviously getting some strong northwest flow. This cold air could be coming off the coast of British Columbia here, bringing some Arctic air even mixed in with this, and really cause some pretty good cascade snowfall in convergence zone setups such as this. Now this is looking at a mid-latitude cyclone. You can see you've got the warm front here, cold front. You can see the southerly flow out ahead of the cold front, the easterly is way up ahead of the warm front off into BC in this scenario. And as this cold front moves by, the flow behind is usually unstable. Maybe you get some of that popcorn cumulus behind it, the low-level instability, cooler west-northwest flow. And that's what we're looking for convergence zone activity here. Let's go ahead and let this play a little bit here, and then I'll pause it. You can see low-level flow wraps around the Olympic Mountains. The cold front is passing the Cascades at this time, so you get that low-level flow, and you can start to get that west-northwesterly flow you need to converge around the Olympic Mountains here, and that's where the convergence zone is likely to set up. And again, depending on this prevailing wind, will it penetrate further south in Seattle? Will it hang out north of Seattle? Just depends on each individual system here coming up. Now, this is some pictures that I've gotten myself here. This is up towards Bothell here. This lightning strike hit pretty close, convergence zone chasing. I don't remember the exact date of that one here. But now we'll scroll ahead a little bit more here. Let this play out here. And you can see this was just north of the Mukilteo ferry terminal there. You can see this convergence zone encroaching on the area. I had quite a bit of lightning with this, as well as some heavy rain as well. Nice time lapse there of that convergence zone creeping south here into the area. So the convergence zone can be pretty interesting looking as well. Some shelf cloud activity in this case. Now we'll go ahead and put that on pause. And this was on the north side of a convergence zone that moved all the way down towards I-90. So a nice view of a cumulonimbus associated with the Puget Sound convergence zone here. So what we're taking a look at now here is my house here just west of SeaTac Airport up against the Puget Sound. This was on July 1st, 2017, and this is a very surprise snowfall here. Some of the models actually hinted at a weak convergence zone across the central Puget Sound a few days in advance, and I'd been watching this feature. I just did not expect it to drop 5 inches of snow in my house in just a few hours overnight, so I woke up to this before I went to work. Just complete surprise, a great surprise at that. I love it when it snows. But anyway, up towards Burien, there were some areas that got 6, but the snow cut off the further you went north, up towards White Center and southwest Seattle very quickly. And it didn't go much further south than this as well. SeaTac got 3 inches of snow, but it dropped off rapidly off to the east. It just shows some of the localized nature the Puget Sound convergence zone can have, especially on snowfall events around the area. So one of the best surprises I've ever been witness to as far as snowfall is concerned. Now, taking a look here, we're going to let this play up. And now we're going to go to a case study on December 1990. So if we go back into December 17th, we kind of check the upper air pattern here. You can see 500 millibars. We had some pretty cold air that was scheduled to move in towards the Pacific Northwest. This was not forecast very well. Back in 1990, they did not have, the weather models were not near as good as what they are today. But now as we go ahead and put this into motion here, you'll be able to see this polar lobe just open up part of the polar vortex just breaks off and comes right down over the Pacific Northwest here. So you can plainly see that. Lots of cold air aloft, prime Arctic blast here across Pacific Northwest. Now as we go on into the surface map here, this is surface pressure the very morning of December 18th. December 18th is when this really hit Seattle. You can see this Arctic high just moving down into British Columbia here, and the subtle troughing out ahead of that Arctic high. And as we go into the morning here of December 18th, you can plainly see this moving down quite rapidly. Very strong gradient. This northerly wind that kicked through the Fraser River Valley was quite strong here on December 18th. But here we are into the afternoon. You can see that subtle troughing across the central Puget Sound there. Not a classic convergence zone here, but still a convergence zone in the aspect that we did have westerlies moving through the Chehalis Gap here, meeting up with some northerly winds here and some northwest winds as the Arctic air started to make its way into the region here. And you can see that Arctic air sag down over southern BC. Very strong gradient, had some powerful north winds behind the system. And we'll take a little bit further detailed look here at the central Puget Sound area. Let's back up a little bit here, back to the 17th. And we had kind of a weak system move through on the 17th. This was kind of the frontal system. And then we had the post-frontal air mass move across the region here. Some low-level flow as this Arctic air started to pour in off the British Columbia coast and come in a northwesterly flow across western Washington. You can see the convergence zone really setting up here about 6 p.m. There was lightning, thunder, very heavy snow in the central Puget Sound here, up over 15 inches for some areas. A lot of places got more than a foot. We got a very quick 4 inches here on Kent, or over there on Kent East Hill. I lived there at the time. And some of the Lake Meridian area, the lake was freezing over at times. A lot of people were stranded in downtown Seattle. And here by 9 p.m., you can plainly see this across the central Puget Sound. And then the northerlies kicked in and moved us much quicker out of the region here for lesser amounts off to the south of Seattle. But again, around Seattle, mainly north, especially 15 plus inches for some areas, along with thunderstorms and a lot of people stranded in downtown Seattle there. Now, taking a look here, let's back this up to the 17th as well. You can see the troughing out ahead of that massive Arctic high dropping down through South BC. Excuse me. And now as we take a look here, we're going on into the morning of the 18th. You can see that Arctic high coming down across. There's the subtle troughing, strong northwest flow moving across the Olympic Mountains, bringing the westerlies and some moisture into the central Puget Sound here, meeting up with northerlies on the other side of that and creating a very vigorous convergence zone across the Puget Sound here. And as we go on into the 19th, you can see how quickly the troughing kind of moved out of the area. It didn't really drop the same amount of snow across the lowlands of Southwest Washington or Portland as it did at the central Puget Sound there. And that's because that wraparound moisture coming through the Chehalis Gap there was able to bring that moisture in and meet up with those northerlies for a Puget Sound Convergence Zone event. Now looking here, let's back this up to the 17th as well. You can see the southerly flow ahead of this system. And then the weak cold front passes through here on the 17th. And then you can kind of see this flow turn northwesterly as we go on into the night of the 17th. And as we go a little bit more into the morning and afternoon hours here of the 18th, look at this northwest flow. And then you can see that gap, Chehalis Gap, really pumping some of that moisture back into there. As this flow starts to turn northerly down the Puget Sound here, you can see it coming out of the Fraser River Gap here, probably getting some slight maybe northwest component around the Olympic Mountains immediately there. But you can see at this point, this convergence zone is just raging across the central Puget Sound here. Nice convergence with the northerly winds and the westerlies, southwesterlies moving through the Chehalis Gap there. Now looking at a little bit wider view here, let's back up to the 17th here, and you can see the 850 millibars, 5,000 feet. You see this Arctic air flowing off the continent and wrapping back around into western Washington. And as we go on into the morning of the 18th here, you can see this air just flowing off the continent. Nice northwest wind aloft coming, allowing for that convergence around the backside of the Olympic Mountains there plainly. But yeah, classic Arctic outbreak there associated with the convergence zone. Not that well forecast way back in 1990. I do remember there being a chance of snow, but I can't remember the exact details besides that. Now going ahead and let's go ahead and take a look at this now. We're going to start talking about the Olympic Mountain Velocity Shear Zone here. Now, again, we talked about the Chehalis Gap there. As this wind flows through here, you can imagine it runs into these mountains and you get an area that's called a lee low pressure here on the backside of the Olympics. And you get some stronger winds just to the south near Port Orchard here, and you get some weaker ones up to the north, and you can kind of create a pinwheel effect. And this will cause some rotating thunderstorms when you get unstable west or southwesterly flow through the Chehalis Gap here. Now, this is one that I took here. This is the Des Moines Pier here. Clear cut, obviously rotating thunderstorm here. And this may have produced a brief tornado. I do not count it as such, but this was a very impressive storm here, strongly rotating. It had a funnel cloud several times, looked like it was trying to drop. It had a few lightning strikes with it as well. This was a similar scenario, a little bit further south towards Dash Point. Again, a product of that Olympic Mountain velocity shear zone there as well. This was also just kind of east of Port Orchard there. And you could see, I don't count this as a tornado because I'm not 100% sure, so I don't count it, but kind of a ghostly apparition there. Kind of looked like it might have been a waterspout / tornado moving across. I think this was Bainbridge Island out here at that point. But now taking a look here, another one. This was last year. You can kind of see like kind of a funnel forming here. Again, a product of that velocity shear zone. So I think these occur a lot more than what we really know, because, you know, when you're on the ground in this area here, your view is limited massively by trees. It's really hard to get a good view. But in the new age of drones and whatnot, we're probably going to get more shots of rotating thunderstorms and maybe funnel clouds and even brief tornadoes across the region here. I did not hear of any reports of there being a tornado here or any damage as such, but sometimes it's hard to pick that up. Now here's taking a look at one that I picked up as well here. This is near Port Orchard here. I was chasing here, and you could plainly see a wall cloud and a funnel cloud with this activity. This is a velocity scan. You can see the winds moving out of the south and then out of the north from behind. So obvious rotation here. You can see it showing up as a thunderstorm here just near Port Orchard as well. Taking a look here, this was actually the Port Orchard tornado, and this actually shows debris being lifted into the atmosphere as far as 10,000 feet associated with that. So you guys might remember that back in December 2018 there, Port Orchard, that EF2 tornado, that is a strong tornado, did quite a bit of damage to some homes out there, moved right past the Walmart there in Port Orchard. Now, taking a look here, we watched this storm system. I was part of Washington Weather Chasers at the time. This one moved all the way off from the ocean out there, and we watched it track all the way across the Olympic Peninsula. We had at least 15 minutes heads up on this producing a tornado here across Port Orchard as well. So just shows that if you understand the dynamics in the location you're at, is such as the Olympic Mountain velocity shear zone, you can predict things like this, that these storms move into that favorable environment. Now, check this out here. So this is from my home here in Normandy Park. Let's back this up a little bit more. And this is that Port Orchard day. Look at that cumulonimbus cloud there. This was the storm that produced that EF2 tornado that hit Port Orchard and damaged those homes. So very interesting. I was very glad that my Nest camera system caught this, and I was able to time lapse it off of that too. So you can plainly see the anvil here from that cumulonimbus as it moved across Port Orchard. Let's go ahead and pause that one here, and we'll scroll up ahead and look at, this is the F3 1969. This tornado moved down into the Kent Valley. It started as a waterspout over the Puget Sound, moved all the way down that hill, down into the Kent Valley here, and did injure one person and did some damage. But look at this. I mean, you don't get much more of a picturesque tornado here in the Pacific Northwest. You can see the older vehicles. This is down where the Boeing plant ended up being. I think the Amazon warehouse is down there now. Somebody correct me if I'm wrong. But yeah, I believe this one was also associated. It looks like meteorologically this was associated with that Olympic Mountain velocity shear zone as well. Now here's my diagram here. Olympic Mountains here. Here's the Chehalis Gap. You can just imagine it there. And of course, in the lee low, the winds are going to be a bit weaker here, and you can kind of get these a little bit stronger winds and even faster winds. You get that pinwheel effect. So any kind of unstable storm that moves through here that's got some cape value, you can see it would add to that low-level shear of the storm system there. Now, taking a look here, you can see it on the weather map, these stronger southwesterly winds here as you race through the Chehalis Gap, and you see weaker winds in the immediate vicinity of the Olympic Mountains here, and that's what causes this velocity shear zone. So you're going to hear me talk about this as we go on in through the fall and winter months, because once you get to October, November, December, it is tornado season out here in the Pacific Northwest. Not that we usually get strong ones, but we do get some brief tornadoes here in the Pacific Northwest. And again, here's another view of that. This is another one too that I chased November 2021. You can plainly see the rotation here. This is near Silverdale. Bremerton, Port Orchard is here, but you can kind of see it still in that same area. Had some lightning associated with it. And I believe this is the one I had with my drone there as well that may look like it was trying to produce a tornado, but I'm not 100% sure, so I do not count it as such. Now checking this out here, this is kind of a forecast that I was making back in September 2021. This actually may have been the one I shot with my drone, but you can see plainly here this stronger shower forming here. And depending on just how southwesterly the flow is, sometimes this shear zone can sit up a little bit further north, closer to Port Townsend, you know, even towards the northern ports of the Kitsap Peninsula here. And they can even, when the flow is strong enough, they can move across the Puget Sound as well. But you can plainly see it here, these strong winds moving across the Puget Sound here and the lee low here on the backside of the Olympic Mountains there. Now here, this was 100-meter wind speed, January 2022. You can even see the little eddy forming here on the backside of the Olympic Mountains here. Just thought I'd show that one for you there too. But hopefully, you know, this gives you guys a little bit more understanding of when I do mention these things. I'll talk about the Olympic velocity shear zone. I'll talk about the Puget Sound convergence zone as we go on into the active weather season here through October, November, December again. And this isn't the only place that gets tornadoes in the region. Really, any place that interacts with terrain, unstable atmosphere can get tornadoes here. A lot of times we get high shear environments and all we need is a little bit of cape and we can kick off some of these weaker tornadoes around the area. And a lot of times the upper level lows will produce enough shear in the environment to produce weak tornadoes along the immediate coastline as well. But I will go over those things individually when these threats do present themselves. You guys probably heard about the Manzanita, Oregon EF2 tornado off the Oregon coast there that did some pretty good damage to trees down there on in through Oregon. I believe that was 2016, if I want to say correctly. I believe it was that storm system that we had October 2016. So yeah, October, November, December, we can really start to ratchet up the active weather around here. So hopefully this helps out you guys. If you have any questions, leave them in the comments below. I can always do another video later if there's a lot of questions about what this all means, et cetera, et cetera. But yeah, I hope you guys enjoy this. I'm working on the top 20 windstorms here. I may do a few more or a few less depending on how it works out here, but we're going to go over the top windstorms all time here for the Pacific Northwest. And we'll talk about those forecasts. We'll talk about what kind of winds they can bring to the area. We haven't had a signature windstorm here in the Pacific Northwest for some time. So I just want to kind of raise awareness about that. We do get some really wicked, life-threatening windstorms here. The Columbus Day storm back in 1962 killed over, I think it's close to 60 people. We've had other windstorms that have killed numerous people. So they do happen. We haven't had one for a while. So awareness needs to be raised on these windstorms. They will occur again. So yeah, if you guys have any questions on the Puget Sound convergence zone, let me know in the comments below. And I will see you guys in tomorrow's, today is September 19th. I'll see you guys in tomorrow's forecast. We'll go ahead and check out that extended forecast and see when we're going to make our transition to fall. So anyways, hope you guys are having a good day. Leave any comments below and I'll talk to you guys later.